Incredible, like sonically, lyric, everything, man. It was just wow, like, you know what I mean? And it made us look at ourselves like, what the fuck are we doing? You know what I mean? This is a masterpiece this kid just made. We with him damn near every day. We outside, you know what I'm saying?
Okay, welcome everyone. Week 3, lecture 2, or 3 times 2 is lecture 6, I guess. So, welcome back. This camera's a little off-centered, but I don't want to screw around with it too much. Yeah, let's see, 120, 130 people so far. Hopefully that number continues to increase. Make sure you get your friends to join the lectures as well. Some good questions in the chat so far. Having a nice chat before the lecture. Anubiva says, I didn't come across the side effects of procedures yet. I don't know how, but I saw them on one of the slides, blah, blah, blah. What's the side effect? What we're referring to here is that when we call a function that returns something, ideally it calculates a result and returns the result, but it does nothing else. Whereas a procedure can do things. So an example of doing something or a side effect could be, for example, printing to the terminal. So that's a side effect. That can happen in a procedure, ideally, but not in a function. You could call a procedure in the function that does that printing, for example. But even then, that could be a side effect. So it's not a hard rule in this case, but it's a conceptual idea. Lots of questions coming through. Yeah, pretty much Windows. Pretty much. A question in if statement, if I want to do nothing, can I just type a close brace, or do I need to type something? Yeah, you can just have nothing in there, I think, but that wouldn't be clean code. You would just be better off not having the if statement or that condition. Yeah, in 151 so far, 1511 so far, we're okay if you can print stuff from functions. But conceptually, some people argue that you shouldn't. You should do printing from procedures, for example. And yes, Nathan, you can do that. You can have return statements within if blocks. That's correct. Betsy, will we be penalized if we have repeating code in the assignment? I think it depends by how much and what you mean and the context. So maybe you need a more specific example, or you can turn it into a function or procedure or something and reuse that. But anyway, we're already 8 past the start of the lecture, so we're going to get straight into it. I think, Leo, we advise against using break in 1511 in general. You can double check the wording in the style guide for that. Okay. Lecture 6, arrays. This is another, just like yesterday when we spoke about functions, this is another really important concept that you're going to use for the rest of your programming career if that's what you go into. And it's going to be really important in COMP1511 as well. So arrays, what are they? What's going on? Just as a quick recap before we get into arrays, yesterday we spoke about some style, good style, bad style, code quality, things like that. And we also spoke about and introduced functions, which is, I think I can already see from a lot of the discussion in the chat and on the forums and things like this, that you're really seeing the benefit of functions and being able to take apart a really long main function, split it up into these reusable modules, whether they be functions that return something or procedures that don't return something, and then they just do something, and being able to reuse them in our program. So that's really exciting to see. And if you're not 100% sure, what's going on with them, you can always rewatch the lecture content and get stuck into them in the Tute Labs next week, I think. So any questions on functions or style? Anything we spoke about yesterday? Okay, all right, I'm going to keep going, and if they come up, we can answer them. And today we'll be looking at arrays. How exciting. Okay, and the other thing is that assignment 1 is going to be released next week. I know you've just finished with assignment 0. You're like, please give us a rest. Nope. But just like assignment 0, there's going to be a lot of support, and actually some additional support for assignment 1 to help you through it. So should be released next week. I'm hoping to. I won't make any promises. We want to release it as soon as possible. We are going and planning an assignment live stream with some of the people that wrote the assignment at some point soon after it's released. And they're going to talk you through exactly the specification of the assignment in a bit more detail because it's a bit longer than assignment 0. And we'll be using the material of the first 4 weeks of lectures. So that means, things like arrays that we're talking about today and functions and things like this. So I know a few of you have been frustrated that you've been limited with what you can use in your assignments because we haven't covered them yet in the lectures. So assignment 1, you'll start to be able to really explore and apply these concepts in your assignment. Any questions on the assignment 1? But again, focus on assignment 0 if that's what you're focusing on right now. And we'll make an announcement as soon as that's released. Bring it on, Jake, we are ready. We'll see. You haven't seen the assignment yet. As always, the live lecture code can be found at this URL. We'll get one of the moderators to post the link in the chat. I'll give that a second. That's it. You got to stay positive. You got to stay positive. You got to stay strong, and you're going to absolutely smash it. I promise. Alrighty. All right, so quick recap from yesterday. What's a function? A function is a block of statements that perform a specific task. And specifically for our functions, they should be returning a result. We have 2 broad classifications. Procedures, which don't return anything, but should have a side effect. So if you call a procedure, it should do something, write to the terminal. Or, there's many other things programs can do. Create a file and things like this. Interact with our computer. So that's procedures, but generally always procedures have a return type of void, therefore they don't actually return anything to the caller. And then we have functions. So functions are the exact same thing as procedures, except they return something. They don't return void. Therefore they return maybe a number or a character or some other data types that we haven't explored yet. So they perform some calculation, read some value, do something, and then give the caller back a result. And both of these are called functions in C. So they're implemented the same way. So it's either a void function, which we're calling a procedure, or a function which returns something. So that's our quick recap on functions. And we spoke about, well, this isn't a functions recap, but this is a recap on readability, reusability of code. Functions help us with our readability and our reusability. If we're doing something in a loop, we can just call the function. If we need to do something multiple times, we can just call the function a second time rather than rewriting all of those instructions that belong inside of a function. And they should, therefore, reduce the amount of lines of code we need in our programs because we can just call those functions again. We're not going to talk about that. I think we'll talk about that after. Okay, so this is what I wanted to jump into. And thank you for the compliment in how the assignments are broken down so that it's not as intimidating. We're doing the exact same thing for assignment 1. Andre says, what does side effects mean in procedure? A side effect means it's the procedure has done something. So if you have a procedure that calls printf 3 times, what's the side effect of calling that procedure? You're going to get some text in the terminal, right? If you have a procedure that creates a file, what's the side effect of calling that procedure? You're going to have a file created. Procedures have to do something because they don't calculate and return a result. So if they're not returning a result and they don't do anything, then they're not doing anything at all, right? They must have a side effect in that term, in that way. Oh, that's not meant to be there. Excuse me, Outlook. Someone says, isn't that the main effect though? Well, I mean, I guess that's the same thing. It's just that is the effect of calling that procedure, is that something should happen. Does that make sense? Don't let maybe the word side effect is throwing you guys off. Nicholas says, when someone says there's a limit to when you write your code, what are you referring to? I'm not too sure either. The limit of what? I would need to know. So is it bad for functions to have side effects? Would we lose style marks? You're not going to lose style marks in 1511. It's an idea that you should keep in the back of your mind, however. And again, any details on style mark stuff is going to be in the rubric or on the course website. Should we use arrays and assessment in the assignment 0? No. There's no need to, and I don't know if we want you to. But assignment 1 you can. All right. Okay, let's get started. So far, let's take a step back, right? So far, we've been able to create variables. Yep, so we can create integers, characters, structs, doubles. So we can create these pieces of memory associated with an identifier that we can use in our programs to store some data. The data could come from the user, from scanf, for example. The data could come from a calculation. So you could store a sum variable, which is, variable 1 plus variable 2 plus variable 3. You calculate the result and store it in an integer variable, for example. So we can have these variables which represent a single type. We can also use enumerations, for example, to define a set of possible values, for example, the days of the week or something like that. And we can also define structs, which store a record of related data. So a user could have a username, a user ID, an email address, for example. Or you could have a results, an exam struct, which is the student ID and the final result of the exam and the assignment results, for example. So you can group different types of data that all relates to the model of one thing in a struct. But what do all of these variables have in common? Can anyone think of some things? What do all of these things have in common? Joe says 1 letter. Jacob says it's a data type. That's correct. They're all data types. 1 character. What do you mean by character? Because I can store an integer. That's not a character. They store variables. They store a single item, says Julian Zincone. They use memory. That's true. Joe says they're different data types. It's a single variable. Yeah, a few of you are hitting the key here. They are variables which represent a single element of some data. It could be a single integer. It could be a single character. It could be a single struct, right? And even though the struct contains multiple things in it, when you have that struct, it's a single thing. So far, we've only been able to store single things. And the reason we have these data types associated with these single things is so that our computer knows how much memory is required to store that particular thing. So the computer knows how much memory is required to store an integer, therefore it knows how much memory to give you when you want an integer. But what if we want to store a lot of data of the same thing, the same type? So what if I want to store a lot of integers? Or a lot of characters, or a lot of structs, for example. At the moment, what would we have to do? What would we have to do if we wanted to store, a multitude of integers, for example? Yeah, copy and paste party. That's exactly right. Justin's on the money as well. We would need separate variables for each piece of memory we would like. we would need to declare a ton of integers. Exactly right. We would need to declare a lot of variables. If we wanted 10 integers stored in our program, we would need to make 10 integers. And then what happens if I wanted 11 integers? I need to recompile my program. Ooh, yucky. And then I'd have to have 10 lines of all these integers. I'd have to name them. Oh, I'd have to go like integer 1, integer 2, integer 3. It'd be awful. It'd be a copy and paste party, as someone said exactly. So, therefore, we stand on the shoulders of giants that wrote these programming languages and designed computers and memory. And those people, knowing this problem, thought, hey, I'm going to help out 1511 students in 50, 40, 30 years' time. And I'm going to have this idea of an array. And I'm going to implement it in the C language. And then the 1511 students, they were thinking specifically of you, won't need to copy and paste party. They will be able to store a collection of elements of the same data type. Yeah, they're prophets, exactly. So in the C programming language, we have this idea of arrays. What are arrays? They allow us to store multiple elements of the same type. That's our limitation. They must be of the same type, but in a single variable. How cool is that? So this sort of diagram on the slide sort of represents that we get this one thing that can store a multitude of elements of the same type. It's like a collection, and they're commonly referred to as arrays. So again, why do we need an array? We've just been speaking about this. If I wanted some integers for the days of the week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, it should be a wrapper or something. We would need to make every single one of those as a variable. And then I would need to remember the name of that variable, look it up, do something. It would be a pain. And that's only 7. I mean, what if I want to store 1,000, 10,000, right? You can see this is not going to scale. This is exactly what this slide is saying. Okay. So we can make arrays that store some number of elements. Because we store them in a single variable, we can access them all at once from that one variable. So we get one variable with one identifier that is able to contain all of the elements. And we can access each individual element of that collection. And we're going to show you exactly how we can do this. Again, I keep saying this, in C, we can only store the same data type in each container. So someone in the chat said, I'm trying to find it, an array looks like a bookshelf with a lot of books of the same genre, I guess. That's exactly right, Anubhav. You can think of it as like one shelf or one aisle in a library. The array would be the shelf that can contain all the books. If I want to add another book to my array, I can just put it at the end, for example. Okay, so that's the brief idea of it conceptually. What's the actual syntax for defining an array and using them? Well, actually, it's a kind of extension to our normal variables of, for example, an integer. If you think about how we would define a normal integer, we would say, well, what's the type of the element? What's the name of the variable? Because it's just a variable, just like all our other variables. However, you can see this bit that's different at the end. Let me just go over here. We need to tell it how many elements we want to store in this array. What's the maximum size of this array, the number of items in the array. And we have to put that in square brackets at the end. And just like that, we have declared an array in C. Pretty cool. Then we need to think about, well, how do I put data into that array? There's actually a few ways to do it. We get this nice syntax here where we can declare, so that declaration is just the same here, and initialize all the elements in the array in one line. We use some curly braces and we would have to put 7 values in the array. some questions we have here. Can we save array in a struct? So do you mean, Jerry, that can you put an array as a member of a struct? You absolutely can. Matthew says, are there such things as heterogeneous arrays? You're referring to this idea that at the moment we're saying our arrays have to be homogeneous. In C, there's no real heterogeneous arrays, but in other languages there are. But there are ways to achieve it in C. But it's not a built-in language feature. But that's going off topic, so don't worry if you don't understand what I'm talking about here. Does it start from 0? They do. We'll talk about that AR11. Does the order matter in any way? Prison Mike says, who I met yesterday in the Tute Lab. That was exciting. The order, I don't know. It depends what you mean. I'm hesitant to say no, that the order doesn't matter. But where the values go sort of does matter. But that's up to you, not the program. Okay. So that's the syntax for declaring and initializing an array if you know the elements that you want to put in it straight up. We don't always, for example. So again, if we look at this line where we're declaring and initializing an array, we're saying I want to store 7 elements in my array, right? 1, 2, 3, 4, 5, 6, 7. These are the numbers, these are the integers I want to put into my array. Remember, because we can only store integers in this array. And you can see that, okay, cool, those numbers get assigned to each element, 3 and then 5 in the array. Now, the idea of this index is really important. What's the index talking about? Well, arrays in C and in most languages are what we call random access. So what that means is that I can actually just individually come in, and let me just, oops. I can just individually come in and read just this element in my array. The way I need to do that is with the index. Therefore, I need to know that the index 3 is associated with this element. And something to keep in mind that indexes always start at 0. So if I look at ice cream consume, I think that's consumed, something like that, of element 0, that would be this value 3 here. So this 7 here isn't the number of the highest index, it's how many elements we will be storing. I'm sure that will throw some of you at some point in your programming endeavors, but that's okay. So like I just said, we can access any element of an array by using its index. That's really exciting. So if I want to access just this element here, I would need to use the index of 2. Oh my God, go away. I would need to use the index of 2. That would then give me the result or the value of 1. How do we do that? You know, what's the syntax in C to actually look up an index and get the value in that position? Well, it's just down here, it's a bit small. And when we type out, we'll write a program to demo this stuff, we'll be able to see that. But you just use the name of the variable, a square bracket, and then the index, the number 2. So this line here, what value is it going to return? Yeah, the value 1. That's exactly right. It looks up the array. It says, okay, I want to go to the index of 2. What's that position going to be? Well, it's the 0, 1, 2th position, and the value in that element is the number 1. Joe says, can an array contain an enum? Yes, it can. Keep in mind, enums are just integers underneath. So can you think about it like the 0 to 6 are the elements? That's exactly right. That's exactly right. Nikhil says, can you nest arrays? You absolutely can, but let's not jump ahead too quickly right now. And the 7 refers to the whole array. No. The 7 here is only used when we declare the array to tell it the maximum size of the array. If you actually ran, does anyone know, let's say I swapped this 2 for a 7 here, what would it do? What would the program do? Yeah, it would break. There would be an error. I don't have memory access in the 7th position, so it would break. It's not going to create a new entry to the array, although that's a reasonable thing to think it might do. But yeah, it's going to scream at you, chuck a fit, and then actually, remember I've spoken about that we have to be very polite to our operating systems. What actually happens is your program will say, "Hi, Mr. Operating System, I would like to access the memory over here." And then the operating system will say, oh, excuse me, Mr. Program, you don't have access to that memory, time to die. Which is sad and unfortunate, but that's what would happen. The program would be shut down. Okay. So a closer look at using arrays. You can't printf the entire array. Okay, so C doesn't know how to print ice cream consume at this point here. It can't say I'm going to print 3, 2, 1, 2, 1, 3, 5. It doesn't know how to do that. So if we want to print an array, we need to tell it, hey, look at each element and print each element in a row. Then it would print. That's how we would print the array. So you can't print a whole array, but you can print the individual elements. Yep. Similarly, you can't scan an entire array. But you can scan each individual element, and we'll do some demos with how to do this. Okay. So Sam says, what happens if you don't know the maximum size of the array for your use case? That is an excellent question. The solution or the answer is not simple. There's a few approaches. One is that you pick a number that you think should be enough, right? In the worst case. So you just say, look, I don't know exactly how many, but 50 elements as a rough maximum is going to be okay. Or you can create the array when you know how many elements you need. Or there's a more advanced thing that we can do in the future that we're not going to talk about just yet. So a little teaser there. Yeah. So Joe says, so arrays are just used to make our lives easier. Yeah, I mean, you're sort of getting the idea. The interesting thing about programming and about programming languages is that a lot of the features of a programming language are not actually necessary to solve problems. They just make our lives easier. So you could have 50 variables. There's nothing that's going to stop that, but it's not feasible, right? Sam says picking a worst case number could be very memory inefficient. Again, the way you're thinking about this is really good, and it's an interesting discussion, one that we don't really have time for. The answer is that yes, we would, in the ideal world, we would want to pick the exact number that is the amount of elements we need to store. However, the cost of getting that wrong and getting a new, bigger array is more expensive than just if we had have asked for a slightly bigger number from the beginning. Does that make sense? So a lot of advanced data structures in programming libraries will actually use some heuristics to determine what size of an array they should request because they don't want to get it wrong. Hi Jake, how would we pull one integer out of the 7 list? Great question. We would do what we've just got at the, I know it's really low on the bottom of the screen, it's a bit annoying, but that, I'll type some, we'll do some coding in a moment, but we would use the name of the variable here, and then the index of the position we'd like to read. So this here would pluck out a single element from our array. Does that answer the question? Okay. So we've said this, you can't print a whole array, you can't scan a whole array, but you need to do everything for the individual elements. All right, well, why don't, before we do that, why don't we, let's see here, just do a brief little example here. Let's go gedit arrays demo.c ampersand, right? We're getting experts at this. Put this over here. Oops. Make this a bit bigger. Let me just move myself over. And why don't we declare and initialize our own array. If you would like to follow along, this would be a good program because we'll keep this program nice and short. So if you want to follow along, I'll give everyone a few seconds to open up, your editor and get started. A lot of questions coming through. Nicholas, what's the difference between, an array equals some numbers or just an array equals 7? In the first case, you're initializing the array. In the second case, you're not initializing the array. Yes, I always forget include standard IO. Thank you. All right, does anyone else need a few more minutes to get set up? Or are we good to go? I'm ready, cool. Anubis, can the size of an array be a variable? It absolutely can. Great question. Great question. Wait, sure, no problems. Oh, it's a question. Wait, what happens when you initialize an empty character array? Good question. Why don't we do something like that? Oh, what would it default to? That's an excellent question. The answer is, what would a variable default to if you don't initialize it? And it's the same thing, maybe. It's not an easy answer, actually. It depends on the operating system. It may not actually default to 0, but let's not talk about that just yet. Okay, all right, I'm gonna get started here. So we have our main function returning 0. I remembered to write it this time. Congratulations, Jake. Let's make a variable that's going to be an array this time. So why don't we do integers, because I think they're a nice simple data type to get started with. And we can call it temperatures. Now this alone would make us a single integer variable that can store a single integer. However, if we want an array, we can say how many elements we want to store in this variable. And just like the example in the slides, we can say, well, why don't we store the temperatures for 1 week? So 7 days. To make this program, we want to make sure we maintain good style. We can very simply say, well, why don't we define the number of days in week as 7, and we can actually use this as the size of the array. Semicolon. Okay, that alone, this is creating enough memory to store 7 integers. So you can actually calculate how many bits this would actually store. It's 32 bits times 7. I don't know the answer to that, but you can sort of figure out that because it knows the size of the array, it knows how much memory to ask for. So this, I might just say here as well, declares an array of 7 elements. or 7 integers, let's say. Okay. Now, we mentioned that we can do something like temperatures is equal to, you know, if we know all the numbers in advance, 32, 21, 32. Why don't we do this? We can do this for now. 21, or 20, I don't know, 21. 1, 2, 3, 4, 5, 6, 7. And this will initialize each element of the array with the appropriate number. Okay, and you could do this on one line. You could do this, for example. Those would both be okay. All right. So how do we print an individual element from this array? Well, really simply, we can just say printf, right? Now, what's the data type? We want to print a single temperature from our array. If I were to print a single temperature, what's the data type of the value I'm going to print? Yeah, integer, %d, %d, exactly right. Even though this variable is an array, it contains integers, therefore nothing changes here. We're going to be printing out %d, an integer, a decimal integer, exactly. Now, instead of just, we can't just put temperatures here, right? Oh, I've used the wrong brackets there. We can't just put temperatures here. Why not? So Spider says we need the index. That's right. Temperatures is the entire array. It represents all 7 values. We're just printing a single integer. So if I want to print, let's say the final element in the array, this 30, what do I need to put here? I use the square braces. They represent an array index, lookup, and I need to put the index. And the final element is going to be 6. Why is it going to be 6? Because we have 7 elements. 0, 1, 2, 3, 4, 5, 6. And so what I expect to see here, if everything has gone okay, is that we clear this, we can compile dcc-o, this is called arrays demo.c, output it, I'm just going to output it to something called program. DCC will not overwrite arrays demo with machine code. Oh, what have I done here? I've got an -o here that I don't want. Thank you, DCC. That was very nice of you. DCC was saying, hey, it looks like you're going to overwrite your actual file, which is not what we want. So that's a nice little piece of emotional support from DCC. All right, so that compiler call looked like it worked okay. Then I can just run program. And I expect to get the number 30 printed out, and that's exactly what I get. That's quite cool. Just like this is quite cool because we've stored 7 integers, right? 7 times 32 bits, and I can read any single element out from that array. And you can imagine, right, if I print, you know, I can go 5, 4, 3, 2, 1. In fact, instead of printing out a new line here, I can print out a space. Right? Oh, I'm missing 0 there. Clear this, run the program again. And there I get all my elements, 32, 12, 20, 21, 25, 33, and 30, mapping to these elements. So there we have proof here that all of these, oh, something's cut off. Is that what you're saying? Oh no, that's okay. Is that okay? Or maybe I misread the comment. So here we have hard proof that in fact everything is getting printed. Is it fixed? Okay, good now. Cool. Awesome. That's really cool. So we can access each individual element. What I can also do, so I can change the elements in the array, right? These, you can think of these as like individual variables within the array. So how do I change? Let's say, whoop, I made a mistake. This 12 was a mistake. Let's say someone said that 12 looks really low. So if we want to change the value 12, what do we need to do? What do we think we need to do? I want to update the element in the array. Ooh, chat's gone quiet. Either the stream's cut off or people are thinking, okay. Alex, can you just type in a different value? We absolutely can, but how do we do that? Spider and Nickel have got an idea there. That's looking really good to me. But Spider, Nickel, why did you pick the number 1? Why are we picking the number 1? You're absolutely right. We use the name of the variable, temperatures, index of 1, and it's just like any other variable. We assign it the correct number. Maybe it was meant to be 21. 21. It's the location. Exactly right. Because 0th is the first element. Right? That's 0. That's 1. Exactly right. You guys are killing it. Okay. Now to prove that that updates, what we can just do is print out that element. So we would expect to see 21 get printed out. Oh, I didn't compile the program. Ignore that. And right at the end there, we see that 21. Exactly right. In fact, I could print all of these to show that, right, we actually updated that element in the array. So with one identifier, temperatures, we can access all 7 elements. It doesn't actually, and we could access more than 7 if we made a bigger array. If you're following along on your own computer, let me know how you're going. Have you come into any syntax issues or something like that? So Nathan, you're asking a great question. Why can't we just use a while loop? You're jumping ahead. You're beating me to the punch. We'll get there. But great thinking, excellent thinking. And Jacob says, how do we initialize the array on one line alone, separate from the declaration? Once again, if you know all the elements, you can do this. This works just the same. Oh, no, you can't. Can you not do this? Or maybe you can't do it. Maybe it has to be when it's declared. Maybe one of the admins can let me know, one of the tutors. Yeah, it's only for when, okay, there you go. I didn't know that. So you can only do it when you're declaring the variable for some reason. I don't see why it would be like that, but there you go. It's only when you're declaring it. But good catch then, good catch. Yeah, I don't think there's any other way to do it. So Cody says, for a yet to be determined array size, can you update the size of it in main? For example, variable name I in a while loop. I don't quite know what you mean. You can make the size of the array be read in from the user, for example, so it can be variable, but once it's set, it's now static. Yeah, okay, can't initialize in a different line. Nikhil says, what if I only wanted the first 5 of the 100 elements to be the 10 and the rest 0? What I would do, there's a few ways to do that. You could just, why don't we pause here for a second, and then I'll show you some more ways that we can be more flexible to deal with our arrays. So I'm actually going to leave this file as it is here. This is our intro demo file. Now what I'm going to do is actually I'm going to copy arrays demo to arrays demo2.c. I'm going to make a new terminal and make that file public. And I'm going to go gedit arrays demo2.c with the ampersand and open it here. So I've made a new file with the exact same source code, but the previous source code is going to also be available. Okay. So a few of you have said, Jake, this, like if you look at these lines, for example, with the printing, these lines here look really, really similar, don't they? And if something looks really, really similar, what should be jumping out at us is that we shouldn't have this duplicated code. We should be able to reduce that duplication. And the way we can do that is actually by using loops with our arrays. I think there's actually some slides on this. Yep, there is here. So if we assign some elements to an array, we can use a while loop and use the index variable, for example, I here, to look up the array index rather than using that number sort of on its own. So how do we do this? So let's say we just want a way to print all the elements in the array. So let's get rid of this. Print all elements in the array without doing it manually, right? If you ever find yourself doing something repetitious or manually, it should be a warning sign that we're doing it wrong, and there's some better way to do this. And the better way to do this is simply with a loop. So we can say, I want an integer variable called I, and I'm going to assign it 0. This is going to represent the index that we're going to be looping with. Then we can just say, all right, well, while I is less than, now, while I is less than what value should we be using here? So Windows says 7. Oh, someone says 6. That's interesting. Someone says 7. Yes. Okay, Jacob's got more where I was leading to. We could just put a 7 here. That would be fine, because once 7 reaches 7, it won't loop, because if I actually used temperatures of 7, that would break. I could do less than or equal to 6. That would be the exact same thing. But by keeping it as less than, what I should actually be doing is using the constant that I declared, which represents 7 anyway. But it just means if we change that number, we're going to be A-OK. So while this index that starts at 0 is less than the value 7, we're going to do something. We always add 1 to I at the end of the loop, otherwise we'll never progress I, it'll just keep looping. And then what we want to do here, let's think about it. I want to print temperatures. I want to print a specific element. I need to put an element in here. I can't put a number because then it's always going to just print that exact same value, that exact same index. If only I had some sort of thing that represented the numbers 0, up to 7. Well, look at that. I have that. I have I. Right? And some of you have already spotted this. I, when we loop here, this increments I up until 7. So I starts at 0, and this increments it up until 7. So if I put an I in here, this is going to actually sequentially access every single element in my array. I here means index, 100%. Irene. And yes, I could use I++ here, but let's just keep it simple and do this. Now, I got to do something with this. I can't just, this doesn't help me. So I can just printf. I'm printing a decimal. Whoops. I'll do a comma and a space. That's fine. And then this is what I want to print. Okay. Why don't we, let's get rid of these. Save this. Let's compile. Well, first let me clear. DCC, this is called arrays demo _2.c. Output it just to program. That's completely fine. Do we have any errors? No, we don't. We're all happy. I run this program and I should see all of my elements get printed, and I'm really happy. Someone's saying that there's no new line. Oh no, there's no new line. What we can do? Well, we can really simply just say printf the new line at the end. There we go. Whoops. Now, yeah, there's still this yucky little comma here, but I'm not going to go too complicated and show you how we can not do that. You could pretty simply, if you think about it, if you're really keen, you could just say if I is actually equal. I can show you, but this is a bit of we don't need to really worry about it. I can just say print the number if I is not equal to the number of days in the week -1. I can printf that comma there. Okay, is that going to put everyone's mind at... Oh, that didn't work. Oh no, that should be... that we don't need the -1, that's all. There we go. But this is just not really necessary. Right, like, yeah. If you want to be really neat and stuff, you can think about ways you can do that. So only print the comma in between. And then I would say, yeah, this is pretty stylish, don't you think? Okay, but you can see, if I don't worry about this, you can see in 2 lines, I can print out every element of my array. And what that means is, if this is, 14 days, right? And I can just really simply do this, for example. I get, well, I'm not putting the comma back in, but I get all my elements printed out without having to worry about it. Right? So you can see why the while loop, if I didn't have the while loop, what would I need to have instead? If we look back at, I shouldn't have closed it. I would have had to have 14 of these, right? Or 12 of these, sorry. No, 14. Yeah, 14. Yeah. And those are pretty still, small arrays. Okay. Alrighty. Do we want to leave this file like this? Make sense with hearing? Yep, cool. I'm going to do a quick little poll. How are arrays so far sitting with everyone? I'm happy. Exciting. Still not 100% sure. So a lot of you are thinking ahead and you're seeing the possibilities, and I love it. But if we take a moment and think right now, how is everyone going with what we've seen so far? I'm curious to see how we're all going. But I really, really love all these questions you're all asking about extensions onto arrays. Goat says, quick question, how can you put void as a parameter to the main function even though the data type is an integer? It returns an integer, but it accepts nothing. There's no input into it. How can you do arrays of arrays? We'll talk about that in the future. Does an additional if statement count as syntax trigger? No, it's just an extra piece of functionality. It's not a syntax feature or a language feature. Julian says, this is a great question. Is there a way to calculate the number of elements in an array? And the answer is actually not in C. No. You need to know the size. You just need to. If you lose track of the size, you're actually kind of screwed. So in C, it does not store the size of the array. So Anubis says, even if we want to do a loop and enter all the values in as the first line as input, do we enter the value one after the other? That is correct. You would have to enter it one after the other. We can do a scanf example now. Okay, Anubis asks another great question. If we wanted to arrange the numbers in an array to ascending order, do we loop through the array and place the smallest one at the first position? That's absolutely true. What you're describing there is a sorting algorithm. They're a little bit more complicated than what you've just described. I don't know if we're going to cover them anytime soon, but you've got the right idea. You need to loop through and rearrange the elements. Nathan says, I found something on the Stack Exchange that does give you the array length, but I think it's convoluted. I can't imagine how they're doing that, but it's out of scope anyway. Okay, Matthew says, all right, why don't we do another quick poll? First of all, let me end this poll. Let me do another quick poll. It's not letting me do the poll. Create a poll. Okay, do we want to do scanf into arrays or hold on, what do we want to show next? Scanf into arrays, sum all values. Oh yeah, and we'll do a break. We'll do a break right now. We'll do a break right now. If you want to quit a program while it's running, you go to the terminal, Samagwita, and you hit Control-C. That'll quit it. Joshua, how do you initialize an array after you've declared it? You have to do it something like this. You have to loop through and just add each element. You can't do this. Yes, everyone, don't worry. We have a Kahoot. After the Kahoot, we'll discuss what we want to do here. All right, so I'm going to take a quick break. Then we'll come and do a Kahoot. Then all we're doing today is arrays, so we'll just keep talking about arrays. So I'll end this poll. It looks like it's sorted at, we want to do scanf. Great choice, everyone. Let's do a break. Let's do a 5-minute break here. I was still talking. Let's do a 5-minute break. Come back, do a quick Kahoot. There's only a few questions. Then we'll keep going on scanf for arrays and we'll do some more stuff at the end. All right. Alrighty. How's that for volume? It's Kahoot time. Chill music over. Is Kahoot music not chill? I thought it was like quite hype. I can't actually hear it because when I play it through the stream, I can't hear the music. Oh, that one's cool. Okay, there's almost 200 people watching. So we should have a few more Kahooters. Maybe people are on their break still. Just fix it. Oh, it's getting pulled off. Anyway, I'll fix it another time. Now, the Kahoot is not compulsory, no stress. It's just for fun. All right. Let's get started with it. We're all good to go. If you were away at your break, I apologize. Oh, a few are coming in now. 3, 2, 1. Let's go. Oh, no. Sorry, Michael. You just missed it. I'm so sorry. Next time. Okay, functions help us do what? Group-related instructions, reduce the amount of code we need to write, can compute a result and return to the caller, or all of the above. I thought you can do Kahoots on your phone, right? I thought you can. Oh, shivers. Can compute a result? Oh, sorry. Okay, you're off. It's fine. It wasn't the right answer anyway. Sorry. Sorry. But 60 of you got it correct. A few of you said reduce the amount of code we need to write. I mean, those are all correct, but all of those are correct. All right. That was just practice. Don't worry. Yeah, they're rigged. I know. Congrats, Simon. Ultra. Interesting. All right, functions always do exactly the same thing. True or false? What an interesting question. Webcams moved, no excuses. Always do exactly the same thing. Very interesting. 25 people said it's true, 58 say it's false. Why is that? What's the argument for true? What's the argument for false? Why is it false? Joe says, why is it false? Exactly. There can be input into a function. And depending on what that input is, the value of that input might change which instructions that function actually executes. So because there's input into a function, the output or the outcome of that function could change. So I kind of see the argument for true. Like, again, Kahoots are a bit of fun. I kind of see the argument that if the input's the same, they always do exactly the same thing, which is completely true. But so maybe there's technically some ambiguity there. However, in general, it might not perform the same instructions every time it's run. So I just picked false. Cool. Okay, true or false? We need to input a library to use functions in C. So like the hash include at the top. This is a good question. So again, your username is hard to read. Do programs not generally behave the same way every time unless there is some kind of bug? What a great question. Wow. Almost 50-50. Killer. Did anyone play that? What was that quiz game? That was like, it was a craze on phones for a while. And there were like live quizzes and you could win real money by playing the quiz. And then it was like a savage question if like a lot of people got it wrong. This is a savage question. Quiz up? I don't know if it was quiz up, but anyway. We do not need to import a library to use functions in C. I think a lot of you, when I miss, hash include standard io.h, a lot of you freak out because you think these programs aren't going to work. Standard io.h is only for printf and scanf and a few other things. It's not required to just make an array, for example. So that was a killer question. Okay, I think there's one more. Simon's still on top. Oh, two more. Input into a function declaration are called what? Input parameters, variables, or arguments. Laventiere says, why can't standard IO be built in? Great question. It's the ethos of C, which is to do as little as possible unless it's required. So a lot of programs don't need standard input, output. Okay, 40 of you said parameters. Congratulations. What was the next big one? Variables. So interestingly, parameters are variables, but they're called parameters when they are input into a function declaration. So they are variables, but they're called parameters. Great question. All right, last one. Oh, I skipped the leaderboard, so that'll be some drama for the final reveal. Input into a function call are called what? Some of you might be thinking, what's the difference between this and the previous question? Are you playing along? Claire says, this is an irrelevant question, no such thing, but what is the difference between C and C++ then? What an excellent question. We can talk about that in a second. Okay, 26 of you said variables again. Not quite. When you're calling a function and you pass the values into the function call, these are the arguments into the function. The arguments map to the parameters. On the receiving end, they're parameters. On the passing end, they're called arguments. Okay, let's see. How did we go? The podium. Jake Stad coming in number 3. Not sure if he would be able to achieve that, but not a bad try. And on top, we're going to have Simon. We've got Simon. Congratulations, Simon. Those were good questions. Yas and Tall Person coming in on top as well. So very well done. Nice. No difficult questions. Don't know about that, but cool. All right. Where's my browser going? Here. All right, and finally, to wrap up the break before we keep going back into arrays, some of you have asked, what's the difference between C++, and then what's the difference between C++ and C#? Good questions. C was an earlier language. Really was designed for low-level computing, so dealing with operating systems. This is actually the reason why you need to include standard input-output to do scanf and printf, because this language is designed and often used for low-level operating system programming where you don't actually need printf and scanf very often. So by default, it's used for systems programming, so it doesn't need it included. C++ came along much later. Programs were getting bigger. People were doing more things with programming. They were running our financial infrastructure. And Bjorn Strustrup, I think that's how you say his name, probably not, had this idea of implementing object-oriented programming into C, and he created the C++ language, which is now very prolific, just as C. And then finally, C# came along. Microsoft designed C# basically with as far as I understand, there's sort of two things that happened. One is they wanted Java, but they wanted to control Java, and they were worried that whoever it was, Oracle or Sun, that was running Java at the time, they couldn't trust them or something like that. They couldn't control the direction. And also it was the idea of what if we took C++ and wrote it from the ground up to handle object-oriented programming, which is something that you don't, sort of need to understand. But I will give you one sort of quick, sort of fun little thing here, which is a totally unrelated thing. I don't even know if it's 100% true, but I remember being shown this and I thought it was pretty cool. So if you, let's see here. Is this the same thing? Nope, go back, home. Maybe this one? Okay, here we go. Supposedly, and again, I don't think this is true, but I've heard this. So first we had C, right? We had the C programming language, and it was really cool, very low level systems programming. Programs were getting bigger. They came along and they said, well, why don't we, sort of add these things called objects to C, which you don't need to understand or know about just yet. Although there's 2521, I think, talks about object-oriented programming, or 1521 or something like that. They extended that. Then Microsoft comes along even later and says, okay, well, what if we write it from the ground up, so we don't worry about what C was doing, and so we add another plus, and you get left with C#, which is the language that Microsoft developed. And actually, I don't mind C#; it's a nice language. And that's one theory as to how we came up with this C# name, that it was C++++. Whether or not that's true, I don't actually know, but it's a fun little demonstration. Okay. Or D flat. Yeah, that's funny. Okay, all right. Yeah, C# came after C++. C#'s a fairly modern language. C# came after C++. Okay. Alrighty. I think so. Oh, that was a nice, actually, little. Anyway, you get the idea. We did the break. We did the Kahoot. I think basically it's just time for demos now. Yeah. So let's go back to my editor. We did the poll and we wanted to talk about scanf. So this is printing all the arrays in, all the elements in an array here. Why don't we bring this back down to 7 to keep it nice and simple. This should end at 1, 2, 3, 4, 5, 6, 7, end here. Okay, keep it nice and simple. Which one's a bot? Okay. I see. Okay. Anyway. Don't know how that happened. But let's say we have... So these 7 elements in our array. We know how we can print them all out. But how can we read into... Yeah, I don't think it's a bot. But anyway. How can we read into the array elements? And really, the answer is very, very similarly. So we can actually just copy this dart, and I know we say if you're copying it's a bad sign, but don't worry, we need to do this. We can copy how we print we can keep that here. Why don't we actually not initialize with that there? So we're no longer assigning any elements to the array when we declare it. But we have this int I here. We started at 0. We loop while we're less than the number of days of the week. That's completely fine. But we're not going to printf here. I mean, I think you should already, hopefully, you're looking at this and you're going, oh, I think I get this, right? I think we can just change this from printing the individual element to reading into the individual element. And we wouldn't want this here. That would not be nice. And let's see how that goes there. Let's clear this. This is arrays demo 2. Okay, this is saying you can't redefine I. That's completely reasonable. If we're going to just use the same variable there, we can just set I back to 0. And that works just fine. And then let's run the program. Oh, hold on. That was working, but what, if we're going to if we're going to scanf something in, it's nice to say, to enter the instruction, right? So enter in the value. So we'll put a printf statement there. Compile, run, enter in the value. I'm just going to say 1, 2, 3, 4, 5, 6, 7. And there we go. We scanned in all the elements into our array. That loop ended. We have our while loop starting again, where we print out these 7 elements. Right, so that's pretty simply how you, oh yes. The bane of my existence is this camera position. Thank you, Tammy. And we can print out all the elements here. Okay, let's read the chat. Some jokes about the trolls, that's completely fine. Anubov, and I hope I'm saying your name right. I've not understood, why do we add the quotes before %c? So why is this a string is basically your question. The answer is that it's just how scanf and printf work. They take in a format string and then the values. So because we can put anything in here, it needs to be a string. Okay, never mind, I might have misunderstood. No, I meant the space. Oh, okay, that's specifically for when we're scanfing in a character. Gotcha. I'm following you now. The reason is we're looking for a character followed by a new, by a white space character. So like a new line or an empty space or something like that. And it's to sort of protect and limit the character that we read in, because there could be, it's not always clear when the end of that character input has occurred. Yeah, so light cursors put it much more nicer than I have. It ignores new lines and spaces in the input buffer. Yeah. Yeah. It's only for characters. Matthew says, if I tried to scan 7 values all at once, what would happen? You could technically do it, but it's really bad practice, because if the length of the array changed, you would have to change the scanf string, and that's not very nice. Yeah, so you put a space before every %c, that's correct. So maybe I'll throw you a question. What if we want to scanf a single element? So we don't want to do it in the array, we just want to do it for, index 3. You can just, you can imagine that you would just go scanf value 3, for example, index 3. All right. Do we need the hash define up here is the question. The answer is no. You could put a 7 here, but this is better practice, because if we want to change the size of the array like we have now to 17, it just updates all of it. Okay, There was one more question that I really liked about how could we sum the values in our array. It's a good question. Why don't I make a new file, gedit sum.c ampersand int main void braces, okay, hash include io.h, whoops, save, return 0, look at me, I'm a pro. All right, so let's say we've got some array. Well, why don't we do doubles actually? So double, so we can have an array of different types, right? So a double array, we're just gonna call it values. And why don't we put 10 values in this array? We can simply say loop int i equals 0 while I is less than 10. I'm not going to make it a constant just because we're sort of hacking around. Or actually, why don't we then say, you know, shouldn't have done 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know. There's some doubles there. Cool. 10 double values in our array. The array is called values. We loop through here. The question is, right, write a program that sums an array of doubles. And of course, this needs to be blah, blah, blah. All right, cool. All right, so how can we do this? We know how to sum an array, right? We just keep adding the numbers together. So if we're summing our values, we need a variable that stores the sum. It's going to be a double because we're summing doubles. I'm going to call it sum. I'm going to assign it 0. In fact, I'm going to do this up here. Like this, because we want to associate the index variable with the loop. So we'll put it straight above it. So we're going to make a variable called sum, and it's going to be assigned 0. We've already got 10 values in our array. So what we want to do here is each time we loop, take the current element in the array, right, and add it to sum. So we'll add 12, then we'll add 42, then we'll add 24, etc. So how do we access the current element in our array? Well, we take the name of the array and we use that index variable because that will start at 0 and increment every time the loop runs until finally I is equal to 10, at which point the array will conclude. So this represents each element in the array as we loop through. And what we want to then say is, well, the sum is going to be equal to the current value in the sum, right, plus the element in our array. And give that a semicolon. And so if we think about this, right, sum is going to start at 0 and it's going to be equal to the current value of sum, 0, plus, if we look at the first element, 12.1, so it's going to put 12.1 in sum. It's going to loop again. Then it's going to take the current value of sum, 12.1, and add values of 2, 42. And in fact, we can sort of make our program describe what it's doing with a printf statement and say well, we can say here, adding %d, that's not a percent, to sum from index, and I can even do here %d. Actually, this is a long float, not an integer. And then we're going to say we're adding values of I, comma, I. Put our \n there. And then after the loop is completed, we can just go printf, the sum is %d. No, it's not long float, it's a double. And then return. Okay, let's run this. DCC sum.c-o to program. Okay, what have I gone wrong here? The sum is, oh, I didn't give it the actual sum. That'll help. So that error was trying to tell me, hey, you've got more format codes than you do variables, right? Because I forgot to add the sum. So let's compile this, clear this, run this, and we should get, oh, I forgot to do a backslash in there, but that's okay. And we get this sum here that gets printed out the end. How exciting. And the really cool thing is that we can even see with our printf statement, you know, it looked at the element at index 0, took the value 12 and added it to sum. You know, and we can even print out, for example, sum. As we go. What have I done here? I forgot my comma. You know, so we can see the sum as it increases each time the loop runs. So this is pretty simply, you know, how it works. And you can imagine, right? It doesn't matter if I've got 10 values here, 100 values here, 1,000 values here. This is an algorithm that sums all the values in my array. Maybe as a challenge for you, how do you calculate the average of the array? I'm not going to do it, but you should, from this starting point, I think it should be fairly, it's not much more to get to the average, but I'll leave that for you. Okay. What was there more we wanted to demo with arrays? So we've spoken about looping for scanning and printing. That's fine. I guess what we can do, one more thing we can do actually. Remember, I do have the number. Okay, yeah. I know the number. I know the number's 10, so I'm just assuming you can use 10. So, yeah, I didn't mean to do anything crazy. You could have a hash define. Right? And then it's trivial. Yeah, I'm not trying to do anything crazy. Yeah, you need to, in C, you always need to know yourself the max size of the array. Okay, there was one more thing I wanted to talk about. How long we got? Yeah, we got time. Excellent. Do I make a new file? Yeah, let's make a new file. Gedit arrays. Oh, I've already got it actually. I already made the file. Okay, here we go. It's a temperature example again, but that's fine. What I wanted to talk about here, because I've already done this, so anyway, that's okay. What I wanted to talk about here is having a user-defined capacity for the array. So it not coming from a hash define or a literal integer, but having the size of the array be something that the user has input themselves. And actually the way we can do that is quite simple. So we can say we're going to be storing temperatures, but let the user pick the number of temperatures to store. Okay, so if we want the user to decide how big the array is, we need to store that number somewhere. And we simply use an integer for this. Array, we can call it array size. Okay, and if the user is going to pick the number, how are we going to get that number into our program? I'm going to hand that over to you all as a question. Yeah, scanf, exactly right. Nothing crazy here. Scanf, %d, comma, to the array size variable. Okay, so we're reading in the size of the array. If we're doing a scanf, it's probably nice to have a printf. How many temps would you like to store? Just like that. Whoops, just like that. Okay, so we're reading in some number. At this point, it's all like, there's nothing even new that we need to do. We can make our array, let's do an array of doubles again, called temperatures. And instead of putting a number here like 7 or a hash define, what am I going to put here for the size of my array? What goes in the square braces? Yeah, exactly right. Array size, exactly right. Do I know how big that's going to be? Do I know how big this is going to be? No, I have no idea. And every time the program runs, it's going to be a different size. So it's telling the operating system, hey, make me an array big enough to store this number of elements. Now this means we can't do initialization like this because we don't know how many elements to put into it. We just don't know. So we need to read them in more dynamically. How do we read in dynamically to an array when I don't know the size? Well, I will know the size. I mean, I'll know it's going to be called array size. Yeah, so I can use a while loop, exactly right, Nathan, and say int I equals 0 while I is less than the array size. Simple. It works just like it was working earlier when we decided the size in the actual code itself. Then we can just say printf, enter the temp for day, and I'm actually going to go %d here, colon, slash, bloop, bloop, bloop. Okay. Maybe you can think about what I'm doing here. Why am I printing out this index? And actually, I'm going to do this, I plus 1. And then we just go scanf. We're going to read in the long float into what? It's going to be our array temperatures of I. Just like that. And then I is equal to I plus 1. We do a whoop-de-whoop, exactly right. All right, this will read in, you're exactly right, I'm missing that there, and no, I didn't miss it there, thank you. This is going to read in an n number of elements into my array, and it's even going to tell the user which day, which number it's reading it into. So if I run this, dcc arrays program.c, output it to program. Okay, getting some, I forgot. So you can tell me here, I don't know what you mean by printf, because I forgot hash include standard input output. Thank you, DCC. Let's clear this. Let's compile this again. Oops, standard input output .h. Thank you. No problem at all. That compiled just fine. If I run this, it says, how many temperatures would you like to store? Let's just store 3. Enter the temperature for day 1. Let's put 50, a sweltering day. Enter the temperature for day 2. Let's put 51. Enter the temperature for day 3, 52, a steady incline, and the program ends. Okay. It's storing 3 elements in my array. Kind of boring though, because I didn't do anything with it. So let's just put some comments here for everyone's reference. Read in the array size, make the array, read in all the elements. All right, now what do we want to do with these values? Yeah, it's a commentary on global warming. What do we want to do with these values? So we could print them all out, again, kind of boring. We could sum them, we could average them. What could we do? Average, that's kind of boring. I mean, we could do average, but we did average, like that was my challenge question. I want you to do average. Indian temperature's not too far from that. Ooh, that's rough. I mean, we get there in summer too. Okay, Jerry, I like this. Find the middle temperature, find the product. I like this, I like this. Why don't we find the minimum temperature? Why don't we find the lowest temperature? That way it's not just some aggregation of an operation like the sum or the product, but it's actually a bit, you know, a bit more interesting. How are we going to do this? Okay, we're going to reset our I variable because we're going to have a loop again. And we know we're going to loop while I is less than the array size. That all stays exactly the same. All right, what else am I going to need to do to find the minimum of an array? We're going to have to work through it. So let's assume that we have some array with the values 4, then 1, then 6, right? So this is an unsorted array, just like our arrays are going to be. We're going to have to loop through each of the elements. So first we'll loop at 4. We'll have to say, okay, is 4, we'll have to store some reference to 4. Then we're going to loop to the next element and say, all right, well, is 4 lower than 1? No, 1's lower, so 1 will become our new minimum. Then we'll loop through to the last one and say, is 6 lower than 1? Yes, no, it's not. So 1 is the minimum, which means we need to store, was this a double array? Yeah, it was. We need to store our minimum. Now, yeah, okay, I'm happy with that. All right. And a lot of you are sort of thinking ahead here, we need to compare each value. That's 100% right. All right, so we have to have some variable for our minimum here. Then we can just say, well, I was hoping to scroll this down a bit, but if it looks okay, that looks okay. We need to say the minimum is going to equal our temperatures at I. So we're going to assign minimum the first value in the array. Okay, so it's going to be 4. And we'll work on optimizing this as we go. We always know I is equal to I plus 1. Now this might seem a bit weird, but then we need to say, well, is the minimum, or is temperatures of I less than the minimum? Now, I don't think this is actually quite going to work, but let's keep it like this for now. Is temperatures of I less than the minimum? If it's less than the minimum, well, our minimum is going to change to be equal to temperatures of I. So only if the minimum is lower is it going to assign it. Now I'm just trying to think, I think this isn't going to work because when the first time it runs, it's going to be 4. Is 4 less than 4? It's going to be no. Then it's going to be 1, and it's going to say is 1 less than 1. So we don't want to do this here. We don't want to assign the minimum each time it runs. What we actually want to do is assign it up here to be the first element in the array. So here it's going to start off by setting minimum to 4. Then it will say, is 4 less than minimum, which is 4. That's going to be no. It's going to go to the next loop. It's not going to assign it there. It's going to say, is 1 less than 4? That's going to be true. And it's going to set minimum there. Continue, continue, continue. And then down here, we can say printf %d. The min is %d \n. No, it's not %d. It's a long float. And print that out. So what would we expect? Well, it depends what we're going to see here. So let's compile this. I've got some errors. What have I done wrong here? Okay, there should be an S there. That's all. Clear that. All right, I is equal to I plus 1. I forgot my semicolon. Thank you very much. Oh, and once again, I keep forgetting here to put my min. All right, and this is compiled successfully. Let's run the program now. It's going to say how many temperatures would we like to store. Well, why don't we just follow our example exactly? Put 3 in. Number 1 will do 4. Day 2 will do 1. Day 3 will do 6. And look at that, it finds our minimum temperature to be the value of 1. How exciting. Now, I mean, this is perfect, right? Like this is a minimum function. We're completely happy here. If I wanted it to be a maximum function, I would literally just have to do that. This is now maximum. If the value in my array is greater than the value I'm storing, now I'm going to find the maximum number. In fact, if I just run and compile this, you're going to see we get that 6 printed out now. Now, of course, you would want to rename this variable, so that's not very, very good practice. But, oh, I didn't recompile it, so this is still finding the maximum. Whoops. But you get the idea. We've got 5 minutes left. That's our introduction to arrays for COMP1511. I hope you enjoyed it. It sounds like a few of you did. What we've got here is just our feedback form. Please complete it. I read every single one of them, and I try and make changes depending on what the feedback is. So if we could put the link into the chat, that would be fantastic. And then in the last 5 minutes, we're going to do some random exploratory stuff in our program. And Timmy, yes, you will never not use arrays now for the rest of your life, I promise. So could we get the URL? I got to just bookmark these or something, because I can't select it here. Yeah, can't have too much ice cream. Maybe I'll just quickly get the link. Okay, thank you, Patrick. It's got the link in. That's awesome. All right, we've got 5 minutes. That's right. Let's go back. I wanted to actually show this function here is pretty good, right? Not just because I wrote it. It's pretty good, but there's actually something we could do to make this very slightly better. Who has picked up what the problem with this is? And again, this is like a post-lecture sort of hangout. So you can head off if you need to, or you don't have the time, or you just want to focus on the basics. This doesn't even really have anything to do with arrays, but Bren, very good, very impressive. Not only did you understand my question, you jumped ahead and put the solution in. Mitchell's got it too. You can just test it in the first while loop as you're putting in the values. Exactly. If we think about what this is doing, it starts at the index of 0. Actually, it was nice to have this. It starts at index of 0, which is 4. It assigns a minimum 4, and then it checks, is 4 less than 4? I mean, there's no need to test, min and temperatures of 0. So how can we solve this? We can actually start looping from the first element. And this is just going to reduce the amount of times we need to loop by 1 iteration. A very small change but this is what we burden ourselves to worry about with programming, is just making things slightly better. No, the lecture code should be accessible. Maybe try again now. Oh yeah, just some, I think just some didn't, because I didn't run that command. Okay, a few of you are asking, it's slightly more optimized. A few of you are asking what would happen if you make the array a size of 0. I mean, we can try it. I don't know why I just compiled it again. It's just, we're going to have a problem here because it can't make an array with a size of 0. So you could imagine doing something like scanf array size. If array size is less than 1, God, I can't, how do you spell Houston? That's embarrassing. Houston, we have a problem. And you could like make the user try again or do something like that. Yeah. Thanks, Kovsky. So you could check. Okay, yeah, head off if you need to. Some good questions in the chat. We're going to have a great day, everyone. Oh, look at that. Tiger VNC just crashed. No, I'm not going to try. Have a great day. It's good seeing everyone. And I'll see you next week. Good luck with the rest of assignment 0.